Hello, geometry students, and welcome back to another video lesson as we continue to explore volume. Today, we are going to focus on both pyramids and cones because they're very similar. They use the exact same formula. First, match each shape with its appropriate area formula. For example, rectangle. Letter A goes with which number? 1, 2, or 3? It should go to number 1. Area of a rectangle equals base times height. How about number 2, the area of a circle? Does that go with 1, 2, or 3? It does go with numero 3. Area equals pi r squared, right? So we need to make sure that we have the radius of our circle. Letter C, a triangle. Hopefully you recognize that it's 1/2 base times height. And again, these are important for volume because we still have to work on finding the area of the base. All right, so for pyramids and cones, the only thing that changes is that we multiply by 1/3 times capital B times H. 1/3. And if you think about a cone versus a cylinder, you know, the cone doesn't stay flat the whole way up. It's meeting at a point. Therefore, we're losing part of the cylinder, which is why we multiply by 1/3. B, this capital B, is still the area of the base. So we need to know what the area of the base is. And the H is very, very specific in pyramids and cones. It's still the height, but it has to be measured from the center of the base straight up to the tip. And we often aren't given it. We're given other information and need to use knowledge from the past to help us find that height. So let's go ahead and look at an example of finding the volume of a cone. Volume equals 1/3 capital B times H. The base is a circle. So capital B in this case is pi r squared. Pi r squared is pi times 25, or 5 squared, which is 25. So the capital B is 25 pi. Okay, so now we're at 1/3 times 25 pi times the height. Remember what I said now about the height. It has to be measured from the center of the cone straight up to the tip. It's this measurement, which we don't have. However, we do have the slant height is 13, which means I could pull this triangle out of the diagram. Right angle, 5, 13, and x, and we can use something to help us find x. Pythagorean theorem. X squared plus 5 squared equals 13 squared. Or x squared plus 25 equals 169. Or x squared equals 144 when I subtract the 25 to the other side. And when we take the square root, of 144, we get 12. 12. So the height of this cone, the height is 12. Now we're going to go ahead and multiply all 3 of those. I can actually do 1/3 times 12 first, since it's all being multiplied. 1/3 of 12 is 4, and 4 times 25 pi gives us an exact answer of 100 pi for the volume of this cone. All right. Why don't you look at number 2, find the volume of this cone, and see if you can't find the radius. We need the radius of the circle down here, which we don't have. How would you find the radius, and what do you get? All right, we got to use Pythagorean theorem again. 15 squared plus x squared will equal 17 squared. Okay, 15 squared is 225 plus x squared. 17 squared is 289. When I subtract that over here, we get x squared equals 64. And if that equals 64, when we take the square root, we get x equals 8, meaning the radius of this circle right there, that radius is 8. We need that radius for a couple of things, right? We need it definitely for the area of the base. Don't forget, volume is 1/3 times the area of the base times the height of that cone. So let's find the area of the base by doing pi r squared, or pi times 8 squared, which becomes 64 pi. So 1/3 times 64 pi times the height of the cone. Remember, this is interior, straight from the middle of the base up, which is 15. If I take 1/3 of 15, that's 5. And then 5 times 64 pi. 5 times 64 is 320. We leave the pi on there for our exact answers because it didn't tell us to round anywhere. If it told us to round, we would just use Desmos and say 320 times pi. All right. Example number 3. All right. Now we got a square pyramid. A square pyramid. Still the same formula. Volume equals 1/3 capital B times H. Capital BH. Base. Let's find capital B. Well, it's a square. So capital B in this case, base times height is 10 times 10. 10 times 10, or 100. So the area of the base is 100. So we've got 1/3 times 100 times the height of this pyramid. Oh no, we're in a small problem again, right? We don't have it. We have a slant height of 13 and we have a side length of 10 and 10. Remember, we need the height of the pyramid to be in the exact middle, going straight up. Exact middle would be how far away from the edge? Well, that would be 5. And then we're looking for this height. So I actually have this diagram. A right triangle. This is the line that's the tip down to the base. We're looking for that height. We know that it's 5 away from the edge because it has to be in the exact middle. And we know that that's 13. We've already done this one, but we'll do it again. X squared equals 20. X squared plus 25 equals 169. Right? 13 squared, 5 squared, or x squared equals 144. When you take the square root of both sides, you get x equals 12, or the height of that pyramid is 12. So if we multiply 1/3 times 100 times 12, or 1/3 times 1200, a third of 1200 is 400 cubic inches. Cubic inches. So again, a lot of it we're going to have to do some math, as I say, to help us find the height of these pyramids and cones. The last example is a triangular pyramid. The base is a triangle and the other sides are a triangle too. So it makes it look, just a little bit confusing, like what is what? The formula doesn't change, so that's the best part. Volume equals 1/3 area of the base times the height. There's a couple of clues now. If you ever see this right here in the middle, let me just circle that, right? It's a right angle right down to the bottom of the base. That is showing you the height of the pyramid. The height in this one is 17. Okay, that's the clue here. They've also kind of shaded the base in for you, so you know that the base is this bottom triangle. And if it's a triangle, capital B in this case is 1/2 the base times the height of that triangle. Formula for area of a triangle. Or 1/2. They do give us the base and the height on this one because of the right angle symbol here. The base and the height have to meet at the right angle symbol. So 1/2 times 8 times 13, or 4 times 13, is 52. So capital B, the area of the base, is 52, which means we have 1/3 times 52 times 17. Let's just use Desmos to help us. Why not, right? 1/3 times 52 times 17, and we get 294.67. 294.67 cubic inches. And there will be directions on a problem like this on what you should round to. So make sure you pay very close attention to where or how to find the height of these pyramids and cones. If you have any questions, please make sure that you reach out. Otherwise, until next time, everyone, stay safe.